Welcome everyone. Let's go through the model. The first set of parameters is a structural grid. So changing this guy to 5 changes the structural grid, as we can see. The next one is the depth. Now, playing around with the depth increases the depth of the building. After that, we have the amount of grids, which is 7 at the moment, but we can easily change that to 9 or 5. The original building has 7, so let's keep it at 7. The floor offset is the difference between this guy and this guy. So if we change this value, it increases, as simple as that. Then we have the amount of segments, so actually the amount of steps that we're taking here. So if we change this 3, it only makes like 3 steps. If we change this to 4, it does so for 4. Let's keep it at 5. The original building has 5. And what we can do as well is that we change around here with the height of each particular step. As you can see it changing. Then we can go to the amount of floors. So this one can be like 45. The building becomes higher or lower. You can see that the segments are still intact. So the segments are relative. Depends on the amount of floors that you have. Let's keep this, bring this back to 38. Then we have like the individual floor height. Let's put this to 3. Let's bring it back to 3.8. I like 3.8. And then we have the vertical offset. For that, let's also use a different preview. Let's go to this preview. The Boolean operation preview. Basically here we have like 2 sets of parameters. So one says something about the height here. So let's change this to 0.5. It gives like a different form language. We can also make it to 1 to make the bezels of the windows very thick. It's basically dictates where the window starts. And the other one that we can do is actually the depth of the windows. Now we can put it to 0.2. And then so the expression is a little bit less. I like the 0.5. It's a strong statement, I would say. I like it. Let's bring this back to 0.8. And those are the parameters that we're using for the Norra Tornen building. Enjoy the tutorial. So the building that we're going to do today is the Norra Tornen building from OMA, designed by partner Reinier Graaf. It's located in Stockholm. It's a pixelated design. I think it's the highest tower in Stockholm. And like I said, it has a pixelated design. And one of the characteristics is that the floors overlay on each other. So like especially this part. And so the 2 vertical floors, they dissolve a bit in each other. And at the same time, that gives the contours to the windows. So this is a nice building to do in a computational way. And in order to do that, we need to have like 2 starting drawings. One is an overview of all the different floors, this one. And at the same time, this one, which is a bit more detailed and fixates on one floor. So let's start with, so we're gonna add like the bifocals, so you can actually see the components that I'm using. So if I delete this guy, you don't see the text, and if I edit, you see the text. So that's the first one. And I also like to keep this one in here, just to see for myself how I'm doing in regard of computational time. Okay, so these are all the parameters that we're going to work with. First of all, we have like the structural grid. So this is the structural grid, it's 4.1. Then we have the depth. So every floor segment has a depth of 16.4. We have 7 grids. So here you see like the grid amounts. There's a floor offset that is because so we have our 2 starting documents, also this one. The pattern of the floor segments are alternating. So here it starts in a Y direction, and then it goes a bit back and then goes to the front again. The opposite is for the other floor. So it starts back, then front, then back. So the difference between this one and this one is an offset of 2 meters. Yes. Okay, let's get back to our main floor. That is this guy. Yeah. Then we have the depth increase. So from here to this guy, it increases 1.5. And from here to here, it increases with 2.7. Then the thing is, because here jumps 2.7 on the alternating floor, it jumps from here to the back, which is with minus 1.2. Okay, and then here we have like the total amount of floors, which is 38. We have the floor height of one particular floor is 3.8. Let's put this one a bit more down. Actually, let's put this one up. Yeah. So the floor height is 3.8 and the vertical offset is 0.8. And the vertical offset is basically this part. So where it's alternating or where it's overlaying between floors. You can see it here. Okay, without further ado, with these ones we can start. So let's start with a plane surface. And with the plane surface, we need to have our x and we need to have our depth. But I like to have this one because this is the plane. I want the plane to be in the middle. There's a nice component for that, and it's called centered domain. So centered domain, this is a component from the Wombat plugin, which you can actually download from the package manager. So no need to go to the food for Rhino. Here you can just do Wombat and you can install it, restart Rhino, and voila, it's there. And I'm also using today like Telepathy, which is a nice way of clean your canvas a bit. So what you can do is you can just bring a receiver in, and all of these parameters that we defined here, we can just bring them in without going all the way to this part of the canvas. So we do a centered here and a centered there. Wait, is this centered? Yeah. And then we do this and then we do that. Perfect. Okay, so how many segments or how many of these floor segments we need? Floor beams, let's call them beams. Correct. We need 7. The grid amount, which is 7. Perfect. So let's make a series. So we want to count of this. We want the structural grids, because with this we create a list that starts from 0 and every time it increases with 4.15 and it does that 7 times. Okay, so here we create our X. So here we have our single floor plates and we're gonna move that 7 times. Yeah, voila. Okay, but now the thing is also, so this one needs to move 2.7, this one 1.5, and then it needs to increase like that every time. So what do we need for this? We need to have here the depth increase and the depth offset plus. Correct. These two guys. And we also need the grid amount. Yeah. Yeah, because let's divide the grid amount by 2. That gives us a number of 3.5 in this case. So that gives us 3.5. And if you round this number, we can round it to either the floor or the ceiling. We want to have both. So we want, because like this is A, B, A, B, A, B. So the A has like 4 values because it starts with A and it ends with A basically. So this is 4, this goes in there. And there goes the 3, goes in there. Yeah. The depth increase is 1.5. So every time it goes further, it increases at 1.5. Yeah. So the thing is that the bottom one, so the B one, starts at 2.7. So this starts at 0 and this should start at 2.7 because this is the 2.7 that we have here. We have 4 values here, 3 values there. So we're gonna weave them into each other. And what does weave mean? So the pattern is 0, 1. So it first takes value from this list, then from this list, then from this list, and so on until you have all the values, which are 7. Okay, because now we're gonna move these guys into the Y direction. Boom, nice. Yeah, actually we have our first floor here. Yeah, nice. Okay, and now also to go back to this guy, so we made this floor. Now let's make this floor. So where this one is to the back instead of this one to the front. Okay, So let's go back to here. Nice thing is we can just copy this whole bunch and we just need to make a few changes. So now we need to use the floor offset. So that basically means that the starting floor is this guy and this one needs to move to this line, right? So we're gonna move this individual to a y of this. Yeah. Okay, nice. So then this one goes there, yeah. And the thing is, so this guy needs to go to here. So we don't put the depth of 2.7. No, we're now gonna work with the depth minus. So instead of going 2.7 forwards in an x-axis, sorry, in a y-axis, it goes minus 0.1, 0.2 back. Actually, now we have our two floor plates. So this is floor A and this is floor B. Perfect. Okay. Okay. Now the next part is, so this is the first part. Now we need the amount of segments, we need the amount of floors, and that is what we need for now. Because now we're gonna make the segments. What do I mean with segments? It's this one. So now we're gonna define these different segments. So we have 38 floors in total. And again, I'm gonna divide it into 2. And why is that? Because we have 19 floors of A and 19 floors of B. Yeah. So wait, what am I doing? This just needs to be divided. Not this. Yeah. So we have 19. Okay. This is my segments. And I'm gonna make a range. So 5 different steps, gonna end up in 6 different values. We don't want that, we want 5 values. So here we're just gonna do x minus 1 and we end up with 5 values. And because 4 steps, you need to have a start and a beginning, so hence why it's 5 steps. Okay, then we're gonna put in a graph mapper. And this one we're gonna put into the WombatGH. I like WombatGH. Yeah, do something like this. So it's gonna read the values at these vertical red lines. So whenever they met, whenever they intersect, that's the value that it's gonna read. And the value is always from 0 to 1. And why is that? Simply because this goes from 0 to 1 and this also goes from 0 to 1. But we can now multiply these values with 19. So the amount of floors that we have. So if we do that, voila, then we have, goes from this to this. So I want to make domains now. And for the domains, we need to also have the number 0. And we need to have the number 19. Because that's how we're going to do it. So we start with 0, then we have all these in-between values, and then we have like 19. And if we flatten this, yeah, we have a list that goes from 0 to 19. So with these values, I can make a domain. So let's make a domain, consecutive domain actually. Yeah. Yeah, so we want to have a domain that goes all the way up to 71. Ah, no, this one needs to be inverted. Yeah, it goes all the way up to 19. 1, 2, 3, 4, 5, 6. So this doesn't match with the amount of segments because we have 6 domains and only 5 segments. So this x minus 1 gonna become x minus 2. Problem solved. Yeah, and the thing is also you want to make sure that there are no double values in there. So let's create a set as well here so we don't have any double values. Okay. Now what we can do is, we know that we have like 19 floors for A and 19 for B. So we're just gonna count 19. And we just want to know how many floors are in each of these domains. And go includes. Yeah, so do this include, and we want to have like each branch, so every domain 1 branch. So we're gonna end up with 6 branches, and all these values we check them for every individual domain. So what we get out of this is a list of trues and false. A true is a 0, sorry, a true is a 1 and a false is a 0. So if we just math addition these values, then we actually know how many floors per segment. So the first segment is 4, the second one 4, 7, 2, 2, right? Okay, this is the first part. Basically, if we put this into a series and we graph this, so a series, so it's gonna count. So there we can end up with 19 floors. And if we graph this, then we actually have our data tree structure, right? Because if I simplify that, so simplify removes all the zeros that are not making sense. So the first segment goes from 0, 0 to 0, 3. Then from 1 to 1, 4. Sorry, 1, 0 to 1, 3. And if we look into this data tree, it does look neat. So here you have your different segments and then the amount of floors per segment. Perfect. Up until now, it goes good. Because the thing is, now we can duplicate the data. So we can duplicate this one and we can duplicate that one. Yeah, we just duplicate it with these numbers and it gives like 133. Yeah, the thing is, so every branch, but if we group it, then here we have like 19 groups and here we also have 19 groups. There's only one thing that we need to do now, and that is this is the group and this is the group. And if we merge them, yeah, and then we graph them, perfect, because from here we can move them into a Z direction, and we can do that with floors, yeah, and then the floor height, correct, because this is the count, so we have this amount of floors and this is the step every time. So, and this is grafted as you see it. You can see that it's grafted by the dotted line. So let's also graph these guys. Yeah, these are now the amount of floors. But what you see is that every segment has every segment higher has one grid less. And so like that part is not in there yet. So this is not in there yet. But just to like show you guys a bit how this currently is looking. Oh yeah, we need to ungroup it from here. Yeah, group it. Yeah, so this group, oh yeah, so then this group it needs to go with the floor height, but also the vertical, yeah. We just do plus. And then let's custom preview this. Let's just do this one. I like this one. Yeah, because you see, like if you just do this one, then you don't have that overlay. It's this floor vertical offset. So let's put that one in. And then we already have our first part working. But let's now bring in the segmentation. So we need to do something here in between, because here we're making the groups. So out of these groups. So what we have here the groups. Yeah. Okay, and we need to make a series of -1 every step it takes. Yeah, and we have how many segments? We have 5 segments. Yeah, so it creates. Yeah, okay. So these numbers. Yeah, so from in the first segment it doesn't remove anything. In the second one, it removes 1, then 2, 3, and so forth. So let's graph this one as well at the moment, and then let's duplicate. Oh, let's just do dd. Oh, I don't have it there. du. Yeah, okay, so what we want to duplicate is this with this amount of numbers. Yeah, because then you get it for every floor. Okay, so if we now graphed it, then we know for every floor. Yeah, so now we know per floor how many grids there needs to be removed. Okay, so let's make another series, the final series, and let's make this negative value positive. And we do this, and we do -1 here, and -1 there. So what are we doing now? So this one is turned positive instead of negative, because like we need the positive for the amount of numbers we need. So now you see all the way at the last floor, we want to remove like 4 segments. So what we need to do all the way at the last floor, we need to have like, it needs to know that how many grids it needs to be removed. So in the last floor, we remove like 4 grids. And in the first floor, we don't remove anything. So let's make a curl index. And this should, so this one goes to 4.1, and this one also goes to 4.1. Perfect. Yeah. Okay. So we do this and we do that. And let's block it for a bit. Let's do, and it should work now, and it works perfectly. Yeah, so here we have like the first part. So where with this guy we can actually play around, like how you want the segments to behave. It's a quite nice thing, I would say. So you can actually have a lot of control, like how you want it to behave. Yeah, and you can also play more. You can, if you do this guy more, it simply is gonna remove more. Simply plus. If we move this one even more further, we can make it really inclined in that sense. It's an interesting way. Let's keep these values back to where they were. Is the correct way? Yeah. Okay, then we can go to the next step. Yeah. Yeah, okay, but this thing all here was for preview actually. Because actually here we go to the next segment. So let's call this floor setup, and from here we can continue. From here we go to floor setup. The button here, add this button here, add the group, and boom, disable it. Yeah, our like computational time is extremely good at the moment. 30 milliseconds to generate everything here. Quite satisfied with that. Yeah, but let's turn this one off. This is what we're dealing with at the moment. Yeah. Maybe this one can also go away now. 38 floors, correct. Okay, let's simplify. Okay, let's shift past these. Let's maybe keep this one in there. Let's shift past these. And do it 2 times. Yeah. So then we bring it back to like each branch, each segment has its own floors in there. And then let's graph this. Yes. Goes to 4, 5. Or like 5 segments. Yeah. And here we can split the tree. And we do so with this combination. Question mark 0 to, yeah, I think this is how it goes. We have 19 here, we have 19 there. Yeah, perfect. Okay, so also the thing I want to do is I want to extend also the surface. I need to ungroup this actually. I can actually do that here. Yeah, do. And I want to do this with, I have my vertical floor offset. Yeah, maybe divide this by 2. And I want to do that on the east and on the west. So on the east and on the west. Perfect. Yeah. Because I will, if I will bring this into this guy at this moment. Then we have like this thing. So like first it was like this. But with this extended of surface that actually goes into each other, right? So this is also a design characteristic of the actual building. So nice guy, perfect. Yeah. So this is going well. Yeah, okay, so this goes in here. Yeah, and here I need to have like my list item, so this we can hide, maybe hide this one as well. Yeah, because I want to have the first one and I want to have the last one, both of them at the same time. So multi-line data, voila, this goes in here, and that looks actually good. It has like, yeah. Yes, I have the first and the last. So this is the first and this is the last, which is correct. Let's also give this geometry. This is a begin, correct? This is a begin. Yeah, and this one we're gonna deconstruct because we were going to want to work with like the vertices. Yeah, so we want to work here with the vertices. And so, because what we're gonna make at this point, now we're gonna make the short facade, right? So we're gonna make these cubes as well, because like this one is fully cubed now. And we need to make the sides. So we have like 4 different things. Yeah, I think I need this one. That's the top one. That's perfect. A plane surface. Let's actually bring this guy back in. Yeah. Okay. Now we have the plane surface. And now we need to make. So let's say we have 2.5. Yes. And we have 6.6. So I already measured these things already by myself. But they need to be negative, both of them. And also this needs to be negative. Yeah, because this is actually what we're trying to do here. Huh? So we're trying to create this. Okay. So here we have the first one. And now we also need to make this thing over there, right? So here we have the first one. That's here. Let's also deconstruct this guy. Yeah, and the numbers we need is a 3.8. Also negative. And we need a 5.5. Also negative. In order to make the plane surface. Let's make the plane surface. Okay, so every surface has like 4 vertices, so I think we need to check which one is which. This is not good. This is good. Okay, so we need the second one. Okay. So let's put this one a bit more there. And actually, now we have this guy. Voila. And we have this guy. And actually, if we make this into a region union, we have our, this guy can go, we have our thing, how it works, how is it looking? Yeah, so we need to simplify them because this needs to be one continuous region union. So this is actually nice. So this works. So like for 19 of our floors, we have this part, which is the easy part because this is the straight part. Also, if we bring this up, this is the straight part. This part is more difficult because it misses some segments at certain point. But we do that one by one. Okay, so we have our first guy. Then let's gonna work with this guy. So this is end 01, and we have also an end 02. Okay, and we need to dispatch. Yeah. Maybe let's move this a little bit here. Let's go a little bit more to the... Actually, it should be more... This is actually the one we need. So this one will go there and there. Yeah. First, we need to dispatch. So we need to dispatch this. And we need to dispatch this based on the number. Because there will be a difference between the equal and the unequal numbers. So we want to divide these ends patterns by whether it's an even or uneven number. The nice thing is you can use here is this, right? So if you divide this by, I think automatically it's 2, or let's just make it 2. But either the number can be fully divided by 2, or you have some left over. So it gives me a pattern of zeros and ones. So we can dispatch this based on this. So this is 12 and this is 7. So here we have like 2 patterns, and here we have the other patterns, which is exactly right. So let's just get along with this. Let's also move this one in. And actually, the nice thing is now we can just fully copy this guy. Let's do that. Let's fully copy this guy. Let's see. Should it? I think this one should go to 2. Is that correct? Yeah, so we need to have different numbers here. So here we need to work with a 7, and this one is not negative. So this one is on that side. Yeah, so basically we're trying to create this one. So to put it broad, yeah, we're trying to create this one here. Yeah. So this is 2.5, yeah, and this should be 4.5, not negative, and this should be 5.5. Yeah, is this making sense now? No, not at all. Yeah, maybe it shouldn't make it from there, but make it here. Here, maybe. Here, actually. Oh, yeah. This is how it should. Yeah. Here we created this one, and it goes from 4.5. This one goes from 2.5. Do see some. It's not gonna. It's a bit much on this side, so I feel in the y direction this can be like 4.5. No, maybe 5. Yeah, 5. 5 is better. Let's keep it at 5. Okay, so this is for the when there's an equal amount of numbers, and we need to copy this to mimic this side. Just continue this. Okay, now we are working here with the 6.6. Correct. No negative number. And this one needs to be 3.8, and this one needs to be 5.5, and no negative number. Yeah. And then there is something very weird happening. That is okay. So we need to work here with 1, and we need to work here with 3. Yeah, this is good because there we have our alternating. This one is only one direction. This one cross each bit. It's not gonna go. This is for these and this for these. Yeah. These we have to. No, this is not going. Okay, so I think we maybe need to put the okay, that's good. Now we have the alternating. Yeah, and then we have this one on the top, which is on this end. Perfect. Yeah, okay. So basically, we can make the same for this goes to 0, 4, and this 4, 4. Yeah. Okay, so we can do the whole same. Okay. Copy this one time. Yeah. But instead we use this guy. and this guy. Yeah. See, this one is going well, I think. Yeah, but we need to have other numbers. So this can be, and this should be 7. And then that going well. No. This one should be 4.5 negative, and this should be 5.5. Yeah. Completely. Okay, so this should be 0, and this should be 2. How does it look? Yeah, perfect. This is the pattern we want. Okay, so this is good. This one and this comes out of it. Perfect. This one is good. This one, this one. These are all good. Alternating between each other. So for the 5th one, so there's the 1st, 2nd, 3rd, 4th, and 5th. Yeah, so 2 and 0. Oh, so this one actually makes sense. Yes. Yeah, so for the 5th one, 2.5, 7 nega. Yeah, 7 mega negative, and this 4.5 and 5 again. Yeah, I think this one looks good. So for the last one, we work with 1 and 3. Yeah, and this 2.6 3.8. I think that's also good. Yeah, so this is good. So the thing is, here A is end 1 and here B is end 2. Here A is end 2 and B is end 01. So it's a vice versa. So actually now we can bring everything together. So this one, this one, this one, this one, this one, this one, and this one. There's a lot, so let's simplify them all. And let's region union all of them. And that works out. So what we get here is basically every floor. So again, we have 38 floors, and every floor is now fully curved. As in, like, each floor has one curve. So this works nicely. So we also have like the expansion of this guy here. So let's call this guy floor setup. It's floor setup 2 because we're wanting further. So here we have like floor setup 2. This region union takes 75 milliseconds, so that is a big jump in our computational time. Yeah, so actually maybe just this is our floor setup. Let's not do the region union here. And actually here we can now check. Let's bring this guy in and let's just say like we're gonna do this now. We bring this open. Yeah. We now have a quite nice, and I think we need to work with the surface to make it a bit smoother. It's closed now. Here you already see like the contours of what we are making, and it's looking really good. Actually looks like the original building already. Kudos on us. So we actually went from this to this. Boom. So the only thing that lasts us now is like making the windows. I do this. Yeah, that's gonna look odd, huh? And the pattern is completely gone. Okay, we're up for the next round. So let's bring our building into this nice asymmetrical overview. So up next is making the windows, subtracting them, and then our building is basically done. Okay, so let's start with generating the windows. So we can start with these screens over here. Let's hide everything at the moment. Is everything hidden? Well, not this one. Something is still not hidden. Yeah. Okay, we continue with this one. We continue with floor setup. Yeah, so here we can actually make like a region union. I need to bring a few things here. I need to bring like the floor, no, not the floor offset. I need to floor vertical offset. I need to bring in the floor height. Yeah. I also need to bring in the amount of floors, and I think that is it. Let's first make like one big like solid union. So this is actually a surface, right? And we can actually extrude this guy into a Z direction, following these two guys. So we need to plus these two. Yeah, correct. Okay, so now we have our floor plates. Yeah. The only thing is now we need to move these guys based on the amount of floors. So here, how many floors do we have? We have this amount of floors. The floor height is this. So these are 38 branches. Well, we graph this one as well. In the Z direction. Boom. This is a first thing. So now it's based on. I am curious to see this guy in action. Yeah, okay. Well, we basically, this is like the, what is it? Floors, union floors extruded. Yeah, perfect. What we also need to do is for every individual here, we're gonna move it up. And basically with this one as well, I suppose. Yeah, maybe here we can also extrude everything. And we extrude it with this guy. Yeah. Okay, because this one is unionized and this is everything still segmented, and this is what we want actually, because here we need to extract. Maybe we need to cap. Do we need to cap? I don't know. Maybe we don't cap. Okay. So let's put a curl index. Yeah. The zeros. Actually, I don't know if we need to extrude. I don't think we need to extrude actually. So let's get rid of the first one and the last one. Okay, 0, no, that's also fine. Okay, so we need to explode these curves because we only want to have the window curves. So basically, dispatch, the thing is with dispatch, there's automatically a true false pattern attached there. So here I probably get the window lines Perfect. So here I have the window lines, almost all of them. Yeah, perfect. Yeah, okay. Here I want to have this one. And here I also want to have the, no, then 0 and the last. Yeah, the thing is here we also just want to have like these curves over here. Okay, so we need to explode the curves. Yeah. To evaluate curve. No, evaluate curve. Yeah. This one back as well. Okay, let's do, so we want to have like the middle point of every curve. Oh yeah, with that we need to reparameterize. So reparameterizing this makes the length automatically from 0 to 1. So in that sense, 0.5 is the middle point, as you can see everywhere. And we want to have like a vector shooting out. So we make an SD line, so it starts at where the point is and the direction is, but here we want to do a cross product. So here we do a vector operation. So we have this tangent, we have the z, and that creates a vector that goes outward. Yes. Okay, perfect. Here we can actually now deconstruct this vector. And we want to work with the x. So the x should be more than 0.9. So that means that it is shooting, no, it should be less than minus 0.9, because we want to have this one and we want to have that one. So let's shoot this 0.9, and a true false creates us a pattern, and the pattern we're gonna use for this one. So let's move all this, and we want to have this guy, and that gives us this. Wait, this should be minus 0.9. Yeah, perfect. This is what we want. Yeah. So this is from one side of the curves. Yeah. So here we have these curves. Oh, yeah. Basically, we want to repeat this whole process. Then with this guy. These guys are my ones over there, and here it's simply the other way around. So we take this one. Let's make an absolute value of this, meaning positive value, and put this one here. This one then should give me all those, and this should give me, and there's 2, 2. Yeah. Okay, so let's start with this. We merge this in here. We then merge. Yeah, the thing is, we want to have like the midpoints from these guys. Yes, and from these ones as well. And from this one, we need to shift path this because we want to have it per floor. And that is then good as well. Yeah. Okay, so we bring this one in there because we still want to bring everything back to floors. Ideally, it should have 18. Yeah, so in the worst, it's always good to simplify to make sure that it is. Yeah. So I'll hide this. I think now we can do this into partition list. So we divide it by 2. And then we move everyone because we want the points to be in the middle of the floor. So we can bring in the floor height. And we just divide it by 2. Yeah. Okay. So now we have these points. The thing is, yeah, so here we have this one we want to move. So these are all the wait. We just need to extrude these ones into the floor height. Floor height. Yeah, that's what we have here. So this one is with the region union curve, so one curve per floor, and this is like every floor has its own still specific thing. So that has 272. So let's bring that in. What you know, we just want to get like the surfaces of the windows. So the thing that we're gonna use for this one is edges from face. So this is my big B-rep, and there are 9. And this is my points, 544. And if we bring this in, it only gives me 1. So we have to do a trick. We have to graft this. Great. Yeah, and then we have like the curves everywhere. One of them, yeah. So we have these. Yeah, so the curves everywhere. Okay, and there are different set of curves. So let's make sure that we separate the curves. Wait, let's do a region, a joint curve. Yeah, that gives us 544. Yeah, okay. Oh, let's simplify this. And we can actually flatten this now. And we're going to sort them based on area. Because how many different sets of, with a great set, so there are 5 different sets of windows. Okay, the thing was this 5 here, we needed to change it everywhere back to 5.5. Yeah, so every value that was 5, we needed to bring it back to 5.5. Because the thing is, we need to end up here with 4 different window sizes. Because with this great set, now we can make like a member index, and here we can actually, wait, this was the flattened tree. So we have like 4 sets of windows. So we have these ones, those ones, and the rest. Thing only is that I want to divide them based on a sorted list. So I want to sort this list based on the amount, the quantity. So I'll put this in and reverse, because so I want to order them based on how many windows. So the one with 329, 92 windows, I want that to be on top. So we make a tree branch and we put in those values, and we do maintain paths. Because now we have the most windows, few windows, few windows, few windows. Correct. So with this thing, we create our facade walls. Perfect. So we have our facade walls, and we can start generating our windows. Okay, so now that we have the facade wall selected, let's start making the windows. And that for that to do, I think the easiest way is to hide everything. We have this nice extruded floors. So let's just use this one as a preview for now. Yeah, let's do it here. Color white. Perfect. Happy now. Okay, so we have these facade walls. Let's explode them. For the first 2 walls, so for these walls, this is perfect. The thing is, we need to extrude. So not only the floor height, but also the vertical offset. Also this one. Need this. Yeah. Because then we have like the full height of the windows, and this is exactly what we need. So let's get the points out of here. Let's make a mesh from it. Nice. So here we have like all nicely meshed stuff. So now we're going to use a plugin which is called Weaverbird. I like it a lot. What we want to do now is like we want to do an offset. So let's create an offset, and this needs to be on parallelogram. Yeah, window frame, but we don't want that. We want to have the actual window. So also put this on parallelogram and put this here. Yes, because here we have the actual windows. And 0.8, this is simply our vertical offset. Right, so here we have all our windows already generated, which goes quite fast, right? And the 0.8, because we use the same 0.8 as we've used for like this extension. And also in width, we did actually the same one. So it works perfect for now. So let's get like the face normal out of this guy. Let's use this one to get the contour of this window. Yeah. Let's move the window a little bit outwards, right? So this is a normal that comes out of it. As you can see, this is the normal. And it's a vector, and a vector always has a length of 1. With the amplitude, we can change this length, which I just want to make it 0.1 because I just want to face it outwards for a bit. Yeah, perfect. Yeah. And at the same time, I want to do this, but then go 0.4 inwards, which should then have like a negative. Yeah. Yeah, so this one goes inwards, this one goes outwards. And actually what I want to do, so it shouldn't be this, but I want to simply create this line. Yeah, so what I want to do is I want to put this point, yes. That should go in this direction. No, wait, in this direction. And get the endpoint and make a line out of it, because we want to make a guiding vector. So this line starts at this point here and it ends at this. So what do we have? We have created this point. Because we're gonna extrude. We're gonna extrude the mesh. So this one we're gonna extrude. This curve, we're gonna extrude it in this direction. Yeah. This one is gonna be inverted. This one is gonna be this. It should be closed. It should be closed as a value of 1. So, voila. So we've basically created our window. Yeah, the thing is, we want this one to go into, so this is 0.1, that is because we've moved this one 0.1 out. So we use the same vector, but since we're using a negative value here, this goes inward, so it goes like 0.3 inwards, because 0.4 minus 0.1, so if we would make this 0.5, it would go in even deeper. So this is the first window set that we generated. Yeah. Okay, so now we also need to generate, so let's also just call this Windows 1. Perfect. Okay, so let's begin with the second set of windows. So here we're gonna do a similar approach. So we start with this. Then we have what we are doing here. Yeah. So here it's important that we need to construct a plane here. Yes, so that can be with this guy. We can actually make like this one, where the y is gonna be the z. So we're making a new plane now. This can go this. And so like this is then the plane that we end up with. And because we want the red line to go inwards and the green line to go up. Now the only thing is that we need to adjust the plane. And we do that with this normal. Yeah. So now we have created a plane where left is red and up is green. And that's the same for here. Perfect. Now we have like a universal plane that we can use for all of them. Okay, we have to check what is the dimensions here. Get like two values. So we graph these values and we graph these values. And we merge them. And we need to sort them. Probably we get like two values out of them. So 4.6 and 7. That goes all the way to the bottom, and 6.6. Yeah, okay, so we have two sets of. We need to remove the. So here we have the vertical offset of 0.8, but we need to multiply that with 2 because we have it. We want to delete it from the right side and from the left side. Okay, so we minus that. So then this is the numbers that you end up with. And here we can actually make like a new plane surface where the plane has just been created. And with the centered domain for both of them. Yeah, we need to work with the list item. We already want to separate them. So this is one. And this is the other value. So we get two values. We get an x value and a y value. And with this we can recreate the place. That's correct. Now, so then these needs to be turned around. Perfect. The only thing is that what we need to do, let's also get rid of this one, is we need to get this thing out. So it needs to be extruded in that direction, and that applies for both of them. So this one needs to be extruded, so it needs to go north, east, south, west. So it needs to extrude west, and this needs to extrude east. So let's. Yeah, so we have two sets, because here we started with two sets of curves, branch 2 and branch 3. Here we actually bring them back into their own branches. And here, this one we're gonna extend with a 0.8. 0.8. No, actually, we shouldn't use this one. We should use the vertical offset. And this should go into the east. It's not correct, but then should go into the west. Is that correct? So this needs to go into the east. Yeah. Then the other branch needs to go into, well, we can leave this one into west. Now it should work fully. So this one is working and that one is working. Yeah, so we went from this to also include this part here, which is one of the points that we need to include. Actually, so now both of these guys we can put in here. Yeah. We make now a mesh out of them. So construct mesh. So we get the 4 points, the contour points. We make a mesh out of it. We get the face normal. We still, in Weaverbird, we get a mesh contour. And with this one, we're gonna get an amplitude, because we take this one, we make it 0.5 into the negative, so that means it goes inwards. Yeah, because we can do this, we can do this, and we can do this. So this one goes inward. Perfect. So now we have this one. We can use actually the same one as we used over here, right? So this is then the direction. You just use a here and then here. Yeah, and this one we created this one. Okay, and this is the Windows 2. Yeah, so we have Windows 1, we have Windows 2. So actually we are sort of done now. Just gonna do like the last bit. Yeah, so we're at the last bit. Let's bring this into together. So these are meshes at the moment. So mesh to poly surface. This is a component from Pufferfish. This is also something you can get directly from this guy here. So let's bring the Pufferfish in. This one you cannot download. Okay, so this one you have to do through Food for a Rhino. Okay, so we are making now all the surfaces out of it. We can actually flatten this now, and we're gonna get the center point. So we can, yeah, so center point. Because we're gonna sort the windows based on its height, so we can actually bring them back into data branches per floor. And so here we can create set. We can do like a member index, voila. And there we can actually from this list, we can bring them back into 63 branches. Is that correct? It's a bit too much actually. Why is this happening? In that case, I think I'm gonna round the height of it and round by 1 decimal. Yeah, we're gonna 1 decimal. And then we're gonna play this game. Then it does so 38 floors. Yes, perfect. So now everything is based per floor. Yeah, now we're gonna do a Boolean operation. So as we here we have like nicely 675 milliseconds per one iteration. Especially this guy is a lot at 345. Bifocals is not taking a lot of time. Shouldn't look at that. So we're gonna do a Boolean operation now. So we're gonna do a solid difference. So this, remember those floors that we made where we used the curve for the whole floor? So that one we're gonna deal now with. And it's gonna go like this. So this is gonna take a lot of time. What do we get out of this? Yeah, the only thing I see here is that this one, yeah, making. Okay, we have to do this twice. We have to do this for this one. This is then Windows 1. We have to do this separate again. Windows 2. This is gonna be Windows 3, where this needs to be 0.1, it is 0.5, and these are created bombastic. This also needs to be negative. Goes out, goes all the way in. We actually need to do this guy as well. Now we have the full building as planned. The only thing is now it takes 7.5 seconds. So these bifocals I'm gonna turn off. So it takes 2.8 seconds. Since you have to do a Boolean operation. Because especially this Boolean operation, this takes 2.2 seconds. That is a big thing. But here, like, we can do the WombatGH. And we can also bring in this guy. Let's do a black. Now it looks pretty nice. The only thing is I want to then also merge face. This is another Boolean operation. But now that diagonal black line is back. Okay, so this is actually the full building. Where we fully made the building. You have a lot of control. It is good though to put this into its own thing, because here we can put like a button, and with this button we add to the group. We can just also work with custom preview with this one. Especially if you want to change things, because if you want to go to like 9 grids, here you can easily change it, and the Boolean operation takes a lot of time, which is like creating the windows. So we can also do 4 segments, we can do 5 segments, we can play around with the segments, and we can make them smaller, bigger. We can do a lot of things with it. And once you're happy with the setup, then it's simple. Then just bring this one in. Boom. You have the nice looking building. Okay, thanks for watching, guys. Until next time. Bye bye.